Our focus standard for this lesson comes from Grade 7, Expressions and Equations, Standard 1, Apply Properties of Operations to Factor and Expand Linear Expressions. Our topic is from the Simplifying Expressions and Equations unit, Distributive Property with Negatives. Our essential question is, what should we be on the lookout for when negatives are in the expression? Please take a moment pausing the video if you need to copy down the topic and essential question into your header, along with today's date, set your question column, and your note column, and resume the video when you're ready to begin. So I always think it's important when we start, the further we get into using the distributive property to expand and factor expressions, to talk about the sneakiest number in math. So the number that I always refer to as the sneakiest number in math is the number 1. The number 1 hides in so many places. It hides under every whole number. So if we want to multiply fractions and we have a whole number there, we can turn that into a fraction by putting 1 into the denominator. And it hides in a lot of other places and expressions as well. Right along with it is its opposite, negative 1. So the sneakiest number in math, I would say, is 1, and sometimes it hides as its alter ego, negative 1. And we really have to be on the lookout for where that 1 is hiding to help make sure that we don't miss an operation or misunderstand what is being expressed in a numerical value or in an expression. So let's go ahead and take a look. So here we have the expression negative 3 times the quantity 4y plus 2. In this case, we can see every value. We can see that the factor outside of the parentheses is negative 3. The coefficient in the term 4y is 4, and we also have a constant term of 2. So in this one, there's no hiding, but there's definitely some negatives, and we want to keep track of that when we are using the distributive property. So from our video lesson on the distributive property, what do you think is the method we're going to use to expand this into an equivalent expression? Well, we want to take this negative 3 and distribute it or multiply it by each term inside the parentheses. So go ahead and think about that. What are we going to get when we take negative 3 times 4y, and what are we going to get when we take negative 3 times 2? Go ahead and pause the video now and write out what you think is the equivalent expression of this in its expanded form. Alright, so let's compare. If we take negative 3 and we multiply it by 4y, we're going to get negative 12y. We are quite accustomed to keeping that operation in the middle, so we kept the plus sign, and then taking negative 3 and multiplying it by 2. So we end up with the constant term negative 6. And this is an equivalent expression of negative 3 times the quantity 4y plus 2 as negative 12y plus negative 6. I will say, though, that mathematicians do not like having two of these operations, this plus sign next to this negative sign, because it gets a little confusing about which one is the operation. So we have, in the past, put parentheses around this to say, well, this is actually a negative sign and it's attached to the 6, and that would be an okay, and we could have done that on the negative 12 too. But we also then could rewrite it as this. What do you think about this expression? We're going to keep the negative 12y, but we're going to change it to subtract 6. So many of you have learned that, well, if you're adding a negative, you can just subtract that value from whenever you're adding it from. And here we're doing that exact same thing, And mathematicians like this as a more simplified expression because we don't get confused about whether or not we're adding or subtracting. We don't see two of these signs here. So the most simplified expression of negative 3 times the quantity 4y plus 2 would be negative 12y subtract 6. Both of these are correct answers, and I will accept both of these answers, but this would be the most simplified form. Let's take a look at another example. For example B, we have negative quantity of 5 plus 6x. Here, we definitely have the sneakiest number in math hiding out. Can you find it? Well, if you said it's hiding right here between the negative and the parentheses, I would agree with you. This really is a negative 1 that is hiding outside of those parentheses. So we have to remember that and say, okay, well, if that's a negative 1, that is the factor that is outside of that quantity 5 plus 6x, and we want to distribute that through each term inside the parentheses. So go ahead and try that out. What are we going to get? When I do this, I get negative 5, and we can keep that plus sign, negative 6x. Okay? And that would be an equivalent expression. However, here we see that again as a plus and a negative or a plus and a minus sign right next to each other. So to simplify it even further, we can write it as negative 5 subtract 6x. And that would be an equivalent expression in its most simplified form. Some of you may realize, though, that here we have negative 5 as a constant term and it's listed first, and in order to be in the correct order, it really should be listed last. So what we're going to do is we're going to keep this because we know that that's supposed to be a negative 6x. So I'm going to say that that is equal to negative 6x subtract 5. And we're going to use that subtraction sign as a negative as well, right? That is a negative 5, so we want to make sure that we can read it that way. So starting from the expression negative times the quantity 5 plus 6x, or opposite of the quantity 5 plus 6x, in its most simplified form and correct order, it becomes negative 6x minus 5. Alright, let's try our last one. Where is the sneakiest number in math hiding now? In this one, we have for expression C, negative 2 times the quantity negative n subtract 7. It's hiding right here between the negative and the n. What this is saying is that negative 1 is actually the coefficient of n. N is being multiplied by negative 1. Even if all they do is write that negative sign. So go ahead, pause the video here, and see if you can expand this expression out in its most simplified form. Let's see how you did. So when I multiplied negative 2 times negative 1n, remember that is our negative 1 hiding there, a negative times a negative equals a positive, so I got positive 2n. And then I kept the subtraction sign, and I multiplied negative 2 times a positive 7. Well, a negative times a positive is always a negative, so negative 2 times 7 equals negative 14. So one equivalent expression of negative 2 times the quantity negative n subtract 7 is equal to or has the same value as 2n subtract negative 14. Once again, though, mathematicians see this double negative right here. And what we learned is the horseshoe method, that we can write that as adding its opposite. Subtracting a negative is the same as adding its opposite. We learned to do that horseshoe method. So the most simplified way of writing this expression is going to be equal to 2n plus 14. So we just have to really be on the lookout for that sneaky number 1 and be really careful about subtraction and negatives in our expression and make sure that we're writing it in its most simplified form. So please make sure that you have all 3 of our examples copied down. If you have any questions, feel free to write those down in the question column and come ready to do more problems like this in class.